All right, welcome to the lunchtime video. I'm going to keep working on my JNCIE-SP, even though I'm moving into a different job role. And it's really not going to be a service provider job role. And not only that, it's not going to be working with Junipers, but I just want my first expert level certification because I think all the work I've done so far is really going to take me there. And it's only another 3 months until the test, so 3 months of work really isn't that bad. And then I'll have the final capstone on this channel to kind of show off, even if I don't pass. And then if I do pass, that'll be, anyone who's looking for a Juniper engineer, I'm your guy if I pass that test. So job security expertise, lots and lots of good reasons to continue working towards this. So let's do exactly that. Okay, and I will share my screen. Okay, so where we left off last, we were working on authentication for IGPs. So we were trying to set it up for OSPF, and then we were going to tear that down and try to set it up for ISIS. And then as a final step, we'll tear down ISIS and then set up OSPF version 3 and authentication for that as well. We also had some other goals where we just wanted more information about what was going on. So to do that, it was, so we wanted to see what would happen if the passwords were mismatched and what would happen if it was configured on one side but not the other. All right, so let's keep going. So this is going to be the 4th video on this topic, kind of giving it perhaps a bit too much time, but let's see if we can get a lot of it done during the lunch hour here. All right, so, yep, 4th video, everything's good to go. All my tags are right. So last video, we had some issues with the lab where the forwarding plane was not being detected. So let's see if that resolved. Yep, so forwarding plane is now online, good. All right, so everything seems good to go. Oops. All right, so let's see here. All right, so we're setting up authentication. So, and we can see we've already got it here. So let's see if we've got a OSPF neighbor. Nope, so we don't have any OSPF neighbors. Nope, so we don't have OSPF neighborship, so I wonder if the password isn't set up on this side. So yep, we do have a password set on this side. Let's see if the hashes match. Okay, so there are different hashes. So the way I understood hashes is if you're using the same string, you'll have the same hash. So let's try resetting it and verifying that the string is the same. So the_SAME. Okay, so we're still not able to connect up. Let's see if those hashes match now. Okay, so the hashes still do not match. I don't know if that's fine that they don't match or not. But I know in like MD5, I think they would match, but this is a different kind of. Nope, this is MD5. So that's interesting. Let's do a monitor start on the T-shoot OSPF. Okay, so we're getting hello packets. So let's do a show int, let's do a monitor stop. And then a show int description. Pipe match R4. Okay, so it's going to be 001. So let's do that monitor start again. Let's do a pipe match. Or instead of a pipe match, let's do or sort of a monitor start, because that command is not going to work. It'd be really nice if that command worked, but it will not work. And I'll show that it doesn't work. So monitor start, T-shoot OSPF, pipe match, 01. Oh, but will it actually match it? That's the question. All right, let's take a look at the link and see if we can figure out why it's not able to form a neighborship. And I think it might have to do with the fact that I set the cost. Nope, I didn't. I don't have that cost setting still altered. Yeah, so all the costs are the same. So I'm not sure why it is not establishing an OSPF neighborship. It looks like this command did work though, where I can just filter out what I want. But here there were messages. Well, maybe not. Let's try filtering out based on this. So we know that there are messages for that. Ah, okay, cool. I actually didn't know that would work, so that's really good to know, especially right before the test. You can just do a monitor start and filter out. So one thing we can do to make this more more useful is instead of that, we can do authentication. Okay, so now, aha, OSPF packet ignored, authentication type mismatch. So that's interesting. So let's do a show configuration protocols OSPF, pipe display set. Okay, so it looks like there's a type mismatch, but I see the type is the same. Let's look at what's in the configuration hierarchy. Okay, let's just delete everything and then just do a simple password. We'll do clouds just like everything else. Okay, and then we'll get our message going, and hopefully we'll see that resolve itself once I change it on this side. Okay, so yep, we've got those messages, good. Okay, so hopefully those messages will now change. Or just stop going. They've been going every, let's see here, here's the timestamp. So every 10 seconds or so. Okay, so now we've got OSPF authentication key with key ID 0 active. So we don't have a OSPF authentication key active, but it looks like the problem is resolved and we don't have those messages spamming anymore. So let's see if we've got an OSPF neighbor. Oh, and we do not have an OSPF neighbor. What the heck? Still have a type mismatch. All OSPF v2 protocol exchanges can be authenticated to guarantee that only trusted routers participate in the autonomous system's routing. By default, OSPF v2 authentication is disabled. Junos software supports MD5 and simple authentication, and beginning with Junos release 8.3 IPSec Authentication. You can configure IPSec Authentication for the OSPF v2 interface, the remote endpoint of a sham link, and the OSPF v2 virtual link. Note, you can configure IPSec Authentication together with either MD5 or simple authentication. To enable IPSec authentication for an OSPF v2 interface, include the IPSec-SA name statement for a specific interface. Okay, so that's IPSec, so that's not going to be as important. So, aha, here we go. So, simple authentication uses a text password that is included in the transmitted packet. The receiving router uses an authentication key password to verify the packet. The MD5 algorithm creates an encoded checksum that is included in the transmitted packet. The receiving router uses an authentication key password to verify the packet. For MD5 authentication to work, both the receiving and transmitting routers must have the same MD5 key. Define an MD5 key for each interface. If MD5 is enabled on an interface, that interface accepts routing updates only if MD5 authentication succeeds. Otherwise, the updates are rejected. The key ID can be set to any value between 0 and 255 with a default value of 0. The router only accepts OSPF v2 packets sent using the same key ID that is defined for that interface. To enable authentication and specify an authentication method as well as a key password for an OSPF interface or virtual link, include the authentication statements. So this is what I did, and I did it at the hierarchy level. Okay. The start time specifies when to start using the MD5 key. This is optional. The start time option enables you to configure a smooth transition mechanism for multiple keys. The start time is relevant for transmission, but not for receiving OSPF packets. Okay. So let's try this. Let's try stripping it off and see if the neighborship comes up with no authentication on it. So just do delete. Show type compare. Quit. I notice how we're only deleting the final part of this. We're not deleting. So the most specific thing is what it deletes. It doesn't delete everything. So if I wanted to delete this interface from here, I would need to put in up until here. All right, router 4. Okay, so let's see if that OSPF neighborship, aha, so yep, now we've got it. We can, just a reminder of what this interface is, we can do a show and description, type match, and yep, it's the router 3. So router 3, of course, is going to have one as well. Yep. Oops, but this is to router 1, so let's do just a show and description. So that one. There we go. Oh, yep. So here's the problem. I was doing it to 000. It has to be done to 001. Okay, so simple mistakes have simple fixes. Okay, and we'll just stick to that simpler authentication method. Oops. Which I don't see. That's interesting. Oh, because I'm in edit mode. Okay, so in set mode, I've got it. Let's go with clouds. Perfect. Now let's run that trace options file again. Okay, and we'll see it say that there is that it's hopefully it'll start spamming the router soon, saying that yep, that there was a mismatch. But now we've got a mismatch from the appropriate router. Before we had it from yeah, 10.0.1.1. Well, actually, no, we still had it from 10.0.5.2 because this is talking about the, yeah. So if I do a show run on here, or sorry, a show configuration. Yeah, so it's this one. So we were getting a clue the whole time that there were other subnets involved. That should have been a huge red flag that, oops, I had the wrong interface configured because there's multiple subnets included in here instead of just one, as there would be if they were true adjacent interfaces. But if it's an interface here and an interface here, you're going to have multiple subnets included. So that's a clear red flag. But we can see we've got our OSPF packets being ignored because we've got authentication mismatches. Let's change our filter to packets. Let's see what we get. Okay, and then let's make it work on the other side because we're still going to get these messages, but we're going to get some more as well, hopefully. Okay, so now we received, oops, well, we're rolling over now, so hopefully we didn't lose any messages while we're doing that, because I've been in a funk lately because I had a final going away. I just went to Whole Foods and bought a bunch of junk food, and oh man, my 35th birthday is coming up, and junk food at 35 is just never a good idea. Okay, so we finally got our messages going. I don't see anything about authentication being a problem. So I'm going to check it. All right. And I don't need to hear anything, so I'm going to put on some hearing dampener just because I think it'll help me focus. So it looks really weird. I get it, but yeah, I do feel a lot more calm and able to focus on this now. Okay, so let's see here. Okay, so I think it's just successful. Yeah, so 5.2, yep, loading full. So we've got configuration, it's successful. Let's take a look at the actual packet. Another thing we can do is have a monitor traffic running on that interface. So I'm going to do that as well. And then I'm going to clear the neighbor and reestablish it. So here it was GE000. Okay, and now we can do a new no resolve on it. That's going to be important, so it doesn't try to use a DNS mapping. Okay, and then do we want the layer 2 headers? No, I don't think those are going to be important. So yeah, I think that looks fine. And then we can do a further matching on it, and it's going to be protocol 88. I forget exactly. Ah, here we go. Yeah, proto 88. That's an additional matching thing we can do. So this is definitely something I need to get really comfortable doing, because it's just a huge tool I have available on the test. And if I don't use it, I'm just basically throwing away a something I can use to be successful on the exam. I'm just not using it. Yeah, here we go. Traffic matching. So yep, this is where I can see. Oh, well, let's see if we've got matching. Ah, here we go. So yep, this is, I read the documentation before. Yep, so matching. And oh, it looks like EIGRP is 88. 89 is going to be OSPF. So that makes sense that I'm not seeing those hello packets, because I should still see those, so it knows to keep that neighborship alive. There we go. Okay, so I've got that running. I've got the Wireshark capture running, I think. Do I? Oh, so okay, so there's a problem where I can't run it. You know what? I don't think it's super important. Let's just see if we can find it here. I won't have Wireshark on the exam anyway. It's just something that I think makes it more clear what's going on. Okay, so let's see what I need to do here. So I need to, right, I need to clear off that neighbor, clear OSPF neighbor, GE001.0. Oops. Oh, I gotta put in the address. So 10.0.5.2. Okay, so now hopefully we'll see this show up, and we'll see that the actual string was sent. Oh, I think I'm not, because I need to do like print ASCII. Yeah. All right, let's try doing that again. Ah, here we go. So you can see, here's that plain text password that I put in there. So yep, this is why it's so important that you you use encryption, because it just gets sent in plain text right in the packet, and you can see I've got it for the hello going this way and for the hello going that way. So these are included in the hello packet. So it's not like the person who wants to intercept this password has to find a particular packet. Nope, it's going to be really easy on them to intercept if you use plain text. So obviously very important to have those encrypted if you're meant to do networking in a secure environment. Okay, so let's do that. Let's set it up with encryption. And then we'll see how it's different. We won't see clouds show up here. We'll just see something else. Let's use key 0. Okay, and now in key, we're going to have clouds just like from before, but now it'll be protected. So if I go in here, now we will see clouds still, but that's just because it's being sent from router 3. So yep, we still see clouds in router 3, but the ones that are sent from .2 to the multicast address, these don't have that in there. It's encrypted. So one thing you can do too is you can line up this with here, but that's a bit too much. But it is important for me to get really comfortable with this because this will be available on the test. So let's change the authentication on this side, and then we'll see these messages go away. We'll see the neighborship reform. Right now we've only got 2. We'll see a third neighborship show up, and then we'll see clouds go away from the packet. Okay, so clouds just like we were using before. So I'm going to commit and quit, and we'll see some messages come up that say that it's going to work now. But even now, just real quick, yep, we can see we don't have clouds showing up anywhere because it's now encrypted. All right, so yep, and now we've got those authentication messages are no longer showing up. So let's do a monitor stop. I don't think there's anything that really needs to be looked at here anymore. And it's just cluttering up the command line. And now let's look at OSPF neighbors, and sure enough, we've got 3 neighbors again. Okay, so now let's get rid of OSPF and set up ISIS, and then we will take a look at authentication for ISIS. And then when we're done with that, we'll just have 1 step left, and that's OSPF version 3. So so we've got this part done. Oh, I did kind of miss my goal of troubleshooting mismatched passwords. Let's actually do that quick. So I'm going to do a monitor start. Yep. And then I'm going to do, and I can do for authentication. So monitor stop, monitor start, authentication, and then configure private, edit protocols OSPF. Okay, now show pipe display set relative and delete. Oops, so set authentication MD5 0 key. Now we're going to do cloud instead of clouds, so they're not going to match. Okay, so no OSPF authentication key active. OSPF authentication key 0 active, but yep, we can see it's not able to go active because because they don't match. Let's get rid of the filter on that monitor start. Okay, so lots of information, perhaps even too much information. Okay, let's fix up that key one last time. Okay, so we can see already that that neighbor came back instantly. So everything's good. So we can cross this one out. Yep, and we can cross this one out. So now it's time for authentication for ISIS. So let's do a monitor stop. Okay, and then let's stop monitoring the traffic here. So one thing we're going to need to do is figure out which IP protocol there is for ISIS, so we can do a similar matching like this. So we won't have that information on the exam. I confirmed with my coworker, you don't have Open Google, you've just got some extra help documents, and then of course you got the built-in help for the operating system. But we're going to need to either memorize that number or figure it out some other way. So kind of my ideal way yeah, ideally, if there was like a chart or something I can look up, that would be the easiest for me. I guess it wouldn't be too difficult to put together some Leifner method flashcards and just memorize the protocol numbers for all the protocols I'll be working with. But of course, the easiest way is to just look it up. So here's some examples, but yeah, unfortunately, I don't see a protocol number. I mean, one thing I could do is just once I enable it, do a monitor traffic and see if I could get it from there. All right, but let's just go ahead and reconfigure everything for ISIS, and then I'll just reiterate that this is possible through a remote connection, as long as you are aware of the source address you are using. So let's go ahead and do that. So SSH, and then my account. Okay, so let's see what happens if I delete OSPF. And I'm going to demo configure exclusive again, just because it's so valuable what it does. Okay, so now let's do edit protocols, OSPF, show pipe display set relative. Yep, now we can do a delete. Yes, top, commit confirmed 1. And now let's try to do 10 enters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see, oops, I accidentally cut off my legs. It's the dreaded, oh crap moment. I can no longer access the device using this source IP, mind you. I can use the directly connected route from router 3 or router 2. But this is the value of that commit confirmed, because if I'm ever in a situation like this, I can put down 1 minute on my outage report instead of however long it had taken me. And not only that, I don't need to roll somebody out onto the site to recover it. It will just recover itself automatically. This is a huge perk to Junipers, so I definitely advocate using it. So it says it'll be rolled back in 1 minute. The other thing I recommend is to do 10 enters after doing commit confirmed 1, because you might be able to sneak 1 or 2 commands in there as it's making those changes. And if you sneak the commit command in there and your configurations really do cut off your legs, they just don't do it instantly. You get a command or 2 before it does, then you'll make it permanent. So I recommend hitting the enter key 10 times after you do a commit confirmed before you do a commit. All right, so I think it's been longer than a minute. I'm really not sure why it seems to take longer than a minute sometimes. Ah, there we go. So, yep, we got a message at 3:19, and then our timestamp. Oh, we didn't get a timestamp for the commit, unfortunately, but everything's good. So our outage report, we can just put down 1 minute. All right, so, but the thing is, we're going to actually need to do that configuration change, but let's just do it in a safer manner so that we don't lose our legs. So show route protocol direct. Okay, so all right, so let's log in from .1. All right, so actually I won't be able to log into the interconnect addresses, but that's fine. I don't need to do that. I can just log into the management IP of a neighboring router. And then I can SSH into router 4 using the source address from a directly connected route. So a show in description, pipe match R4. Okay, and I'll show configuration interfaces. All right, so let's do SSH. .2 source. Oops, so actually I remember what I did last time. There we go. So yep, I had a special user account for logging in via router 3. So now I can make all the changes that I want in the world to the IGP and not lose management access. Okay, so let's set up ISIS. Okay, so everything's good to go now. On this one, oops, actually, never mind. I missed a step. So not only do I need to configure family ISO on interfaces, I need to add the interfaces to the actual ISIS protocol. So let's try that. Oops. Okay, so now ISIS is good to go on router 4. So let's do a monitor traffic and see if we can figure out what the IP protocol number is for ISIS. So there should be some ISIS traffic leaving. So here's the priority and the length, but I don't see the protocol. Yeah, really not sure how I would find the protocol number. I see the priority is 64. That's what PRIO stands for, I believe. But the protocol number, I'm not sure. I will look it up. Okay, so the Wikipedia is usually good, so hopefully we can get the number from here. Oops, I don't see anything. Yeah, see, that's what I thought. The protocol number is going to be listed somewhere in the packet. So I should be able to get it just from the capture here if I do a print ASCII. Ah, it might just be because I don't have no resolve on there. Ah, here we go. So now I get a .22, but that's the port number. Ah, and it is just giving me the name of ISIS instead of the what I would think is the protocol number. But we can use Wireshark. Well, I guess we could if it weren't glitching out. I think I'm gonna call an end to the video here. In the next video, we'll finish setting up ISIS. We'll set up authentication for it. Then we'll strip it down, set up OSPF 3 and with IPv6, and then set up ISIS on that too. And then that will be the end of this topic. Hopefully I can get it all done in one after work video today. And then we'll be moving on to a new topic. So thanks for watching, and I'll see you in the next video.